ऐकू येत नाहीये हा अजून सर.
Hello. Hello.
हा आता
हा येते
येस
आता.
येस
Yes,
या
yes. Okay, very good. So last time we have seen the method of Aryabhata to find out square root, cube root, and the idea was that you can also find out fifth root and any nth root by the same method. So hello. So let me just go through that part. So this is just slightly better explanation than I gave last time, that you have a two-digit number AB, and from that small a, which is a digit, we can construct this capital A equal to 10 times A. And the juxtaposition A B of two digits is corresponding to capital A plus B. Capital A is 10 times A, and capital A plus B bracket cube will be A cube plus 3A square B plus 3 capital A B square plus B cube, and that is suppose our number capital N. So capital N is our cube, and it has a cube root which has two digits, and capital N is 10C plus D. Suppose mod 100, suppose we want to look at it mod 100, that means last two digits we get from this. So this is the method of getting cube root from last two digits of the number that I discussed last time. And our cube, it has two ghanasthana, cube places, and therefore the cube root will have two digits. These two digits are A and B. And then how you get this cube root from the given number capital N? That is what we want to discuss. So if our number capital N is cube of A, B, so it is capital A plus B cube, and then capital N is our number which is congruent to 10A plus 10C plus D. N is congruent to 10C plus D modulo 100. That means last two digits of capital N are C and D. And now if you simplify this mod 100, then it is 30 AB square plus B cube, that is congruent to 10C plus D modulo 100. The other part actually disappears because you want modulo 100 only. So if this B cube, if you consider modulo 100, okay, so B cube you write as 10 B dash plus B double dash modulo 100. So B is the last digit actually of the cube root, and B cube is congruent to 10 B dash plus B double dash mod 100. Then B double dash will be actually D, because 10 is in this part, and therefore B cube, its last digit, that is B double dash, that B double dash has to be equal to D. So So B and B dash are taken to be of one digit. Taken to be of one digit. Yes. Therefore, you simplify it 10. So that B double dash gets cancelled, and we are comparing with AB cube equal to n. This AB cube equal to n, this thing where n is 10C plus D modulo 100. So you see that B double dash equal to D, so that part gets cancelled. And what we get is 10 AB square, 30 AB square plus 10 B dash is 10C modulo 100. This is what we get. Again, you can divide by 10 and you get a congruence. 3AB square plus B dash is congruent to C mod 10. Now, here we know B dash and we want to find out B. No, we want to find out B, that is our aim. So if we find B dash, that will be good. Okay, so you divide by 10, you get this equation 3AB square plus B dash is congruent to C mod 10. Now, if B10 is equal to 1, so B is the last digit and B10 is equal to 1. That in that case, we can obtain, so then A can be obtained uniquely from this equation, because 3AB square plus B dash is congruent to C mod 10. So B dash you can take to the other side, and then you can solve the congruence equation and A can be obtained. So this is the method. So first of all, if the cube root has 2 digits, then we find out the last digit B first of all. From the last digit, you find out B cube. And then B dash and B double dash you can find out. These are the last 2 digits of B cube. And then you get a congruence equation for the digit A. So 3AB square plus B dash congruent to C modulo 10. If B is co-prime to 10, that means B is an odd number and B is not divisible by 5. Then you can solve this congruence and get the value of A. So A is the last but one digit of the cube root. So from this, so this example is there 148877. This is the number, and you group into 2 parts, 148 and 877. That means the cube root has 2 digits, and we want to find out these 2 digits. So from the last digit 7, 7 is the last digit of the cube, and so cube root must be 3, because 3 into 3 is 9, 9 into 3 is 27, so last digit is 7. So 7 corresponds to 3. So the last digit of the cube root is 3. Now if that is 3, then the other digit is suppose A, then 10A plus 3 bracket cube is congruent to the last 2 digits of the cube, which are 77. So that is 77 here, last 2 digits of the cube. So we get this congruence equation, and then you expand this cube and you can see what happens modulo 100. So 10 cube disappears and 100 also that goes. So 30 into A into 3 square, that is 9, plus 27 is congruent to 77 modulo 100. So you can you can cancel 7 for example, and you get 30A into 9 plus 20 is congruent to 70 modulo 100. So you can divide by 10, take 2 to the other side, and you get 7A congruent to 5 modulo 10. Now to get A, you may multiply by 3. So you get A congruent to 5 modulo 10. So the cube root is 53. So the point is that whenever the power 3, that is you want to find out cube root, so that 3 is co-prime to 10, then instead of the method of Aryabhata, you can use only the last two digits. And using the last two digits, you can solve some congruence equations and you can get the last two digits of the cube root. But cube root has only two digits, so you have obtained the result. Yeah. So similarly, if that was the idea which must have used by Shakuntala Devi that I mentioned, that in the Shakuntala Devi's case, she had to find out 23rd root of a number which has 201 digits. And therefore, from that, first of all, one understands how many digits are there in the 23rd root. And the number of digits in the 23rd root is equal to 9. That we can see easily because you can group 23 numbers digits together, and that is how you can get 9 groups out of the 201 digits that you have. And therefore, because the power 23 is relatively prime to 10, you can use this method. And you should also see that the number whose 23rd root we have to find out, that its last digit should also be odd actually, 1, 3, 5, 7 or 9. And that means it should not also be equal to 5. In that case, what you can do is, you can use the same method and you can use the last 9 digits in that 201 digit number. Only last 9 digits you have to look at, forget about the remaining. And from these last 9 digits, you do these congruence calculations. And because the answer is unique, you can every time solve these equations one by one. You get the last digit, then previous digit, like that. So go mod 100, go mod 1000, 10,000, and use the previous digits obtained to get the next digit. So by the same way, the method will work. And this is an illustration when we have only two digits in the cube root. Same method works for any power. Means you want to find out, you are given a 47th power and you want to find out 47th root. Then you have to find out number of digits in the 47th root, and then find out if 2 and 5 are there at the end. Then what one does is, because it is given to be a, say, 23rd power, it is given, so 2 will appear that many times in that 23rd power. 2 will appear 23 times. That I only mentioned last time, that if our number is divisible by 2 or 5, the given number, then you just divide that 2 or 5 that many times, 23 times, for example. So again, if there is 2 remaining still, again, because once it is there means it is there 23 times. So and that kind of thing is easy. For example, if there is 5 at the end and you want to remove 5 raised to 23, then you multiply by 2 raised to 23, and then you get so many zeros at the end. Those zeros you can just get rid of. So that small argument we can do modification. So in the Shakuntala Devi's case, that number was actually odd number and not ending with 5. So she doesn't have to do any further modifications of this type, and directly she could look at the last 9 digits and get the answer. So this I only mentioned last time orally, but if you want to really write down the argument, then that is what you have to write. What happens if the number is even? What happens if the number ends with 5? Then there is small modification because of which you reduce to this case. And if you reduce to this case, you can use this argument for any number of digits. You can do that. Okay. So, yes. You should know the proof, yes. So, I mean, more steps one has to write for this thing if you want to. So, there is some theory involved which also is to be explained because it is not actually there in any book. So, one has to just develop this theory, and maybe an illustration of this type is enough. That 2 digits or 3 digits, how will you get? That much calculation can be done somewhat easily. Yeah.
Yeah,
No.
especially the skin.
No, this. But by using computer, it will be immediate. Means the same, because the method is there, and instead of coming from the largest numbers, you start from smallest numbers. Then you are essentially getting the answer immediately. And I think that because Shakuntala Devi did faster than the computer, so probably computer did not did not use this method, is what I think. Totally different way. Yeah. Yes.
Finally, it's much difficult for us multiplication.
They do that.
But then multiplication.
They must have done by some other way. Anyway, so I think people get the idea how this can be done very effectively, and the congruence method works. Congruence is another word, yes. That is important. 1000, yeah, like that. Every time you get one more digit. Yeah.
What is the corresponding for binary?
No, binary system, it will be the same thing. Now, only thing is what you require is the number should be relatively prime. So it should end with 1 always if you convert to binary. Yeah.
Whatever you say here, base.
Base. Yeah. No, that seems to be, that is, yeah. Because
If the base is 8,
Hmm.
then it's 8 or R.
But you take it different ways, the primes or change.
primes means the digits in that those primes, they will change. Primes will remain prime.
Primes divided that base, they make a
10 will be yeah, so primes will look different, that is true. Hmm. Hmm.
What happens with binary? There are digits. So
0, 1. Okay, so people can Hmm. So this is for cube root. Cube roots, if you want to find out, and then every last digit will give rise to a last digit for a cube root in this way. 2 cube is corresponding to 8. So 8 will correspond to cube root digit 2 and so on. So if you want to use this method and find cube root, then what you can do is, suppose I want to find out 50653, 50653 and its cube root. Then you have two groups, one is 50, another is 653. And the answer is 37 cube. But this 50, if you look at this 50, then 2 cube is less than 50. So that tens digit is 3 from that. And the last digit of the cube is 3. And if the last digit is 3, then 7 is the corresponding cube root digit. Digit in the cube root is 7, because 7 is 7 into 7. So that is 3. That corresponds to 3. So this way, you are combining Aryabhata's method and the congruous method together to get the cube root immediately. He does not use congruences. He uses the binomial theorem. He only uses binomial theorem. This thing I am telling, here I am using binomial theorem. So first step of the of Aryabhata I am using. First step, that is you find out the largest cube which is less than or equal to 50. Hmm. Means Gauss only introduced the notation, but the idea is there because people used to talk about remainders, right? They will say find out the number n which leaves remainder 2 when it is divided by 46, 49, like that. So idea Gauss made the things simpler by using that notation of congruence. Things become somewhat easy to explain. Yeah, it becomes very clear because congruence is like equality in the modular system. So this is how we can find cube roots quickly. Okay. This is fine. Now this is the method I explained. What is used by Aryabhata in his formula. So if we have a 2-digit cube root, then one uses a plus b cube equal to a cube plus 3a square b plus 3ab square plus b cube. So first of all, from the given number capital N, one is subtracting this a cube of a digit a, and it is placed at the appropriate place. It is kept at the appropriate place, and then we are subtracting. Then one finds out b. So what does one do? One subtracts a cube, and then you are dividing whatever remains. You are dividing by 3a square, and find out b. That b is used, and you further subtract 3ab square, and further subtract b cube. So if a 2-digit cube root is there, then this is the formula that is used by Aryabhata. But then suppose there are 3 digits in the cube root. Then in that case, what happens is you are doing these calculations and you are subtracting this whole thing first of all. But this is a plus b cube that you have already subtracted. After that subtraction, whatever remains, that is divided by 3 into a plus b square, which is here. You are dividing whatever remains by 3 into a plus b is a 2-digit number. It is actually corresponding to 10a plus b. And then whatever division you get, that you are writing as c. This c is also actually adjusted. It can be c minus 1 also, means the previous number also. Once you get c, you are further subtracting 3 into a plus b into c square and further subtracting c cube. The effect of all this is you are subtracting a plus b plus c bracket cube. That much you are subtracting. So after that subtraction, still suppose one more digit is there, suppose that is d. Then the meaning is if you subtract a plus b plus c plus d cube, then you should get 0. That is the actual idea. So far you have subtracted this much, a plus b plus c, and here up to this you have subtracted. Then you have to find out d after this, suppose. Then you divide whatever remains by 3 into a plus b plus c bracket square and get d. Then get, so once you get d, you subtract 3 into a plus b plus c into d square and further subtract d cube. That means so far you have subtracted a plus b plus c plus d bracket cube, and still suppose something remains. Then one more digit is e, suppose. That e to be obtained, for that you have so far calculated up to this, subtraction done up to this, and then whatever remains you divide by this 3 into a plus b plus c plus d bracket square and get e. Once you get e, you further subtract 3 into a plus b plus c plus d into e square, further subtract e cube. Then if you get 0, then matter is over, and you have got 5 digits in the cube root. So this advantage of this method is that whatever you have done earlier, that is not wasted, even if there are more and more digits. That is the advantage. That information you don't have to keep. Keep means that already is done. You can forget about that. And no. when substitute means, so let me just go to an example.
Someone is find A.
Now see, certain things are actually remembered in this. Let me go to the previous example. Then this thing will become more clear.
Says you take A, B, C, D, E.
Yeah, that's right. But
Suppose
let us look at this. So what is happening is we are only remembering those digits 1, 2, 3. It is sufficient to remember that thing. That is so what Aryabhata says is you write those separately somewhere. These digits in the cube root, those you have to anyway because you want that at the end, no? So that anyway you have to have. So that you write separately, he says. But here what happens, whatever calculations you have done, you don't have to remember the in-between calculations. Because what happens is, now this subtraction you have done, you have got this. This 6, 8 you take from above. Yes.
you have the case, you correct the case A.
Yes.
Then you have to subtract that A cube.
A cube, yes.
That itself is some calculation. Now you have to
Yeah. One has to do that calculation and go ahead and further subtract. A cube is subtracted.
minus getting some other digits.
Yes, that's right. But the previous calculation we don't have to remember. Means what is happening is these numbers are replaced by essentially these new numbers. That is the idea. Like when the subtraction is done and you get 0, 8. Okay, then you are taking this 6 which is already there. We cannot forget these numbers in any case. And you take this 6, and then you subtract, then you take the upper number. Okay, after that this you can forget whatever you have done. So it is kind of what is called saving the computer space. So in between things you do not require later, and you can replace the original digits by the new digits that we have obtained. For example, what you can do is this 2, 8 we can forget. 1 I can forget. I can forget this 8 also once I do this calculation. Okay, and instead of 8 there itself I can write 2. I can replace that 8 by 2 and I can just use that next 6. Means whatever we are doing here, I can do here itself. That is the idea. That replace 6 by 2. 6 is taken just now. Okay, so replace 8 by 2. Then you get 26. Subtract 12 and you get 14. So you replace this 14 here. You take it here. Then you get 140 here. There itself you subtract this 8. There itself you can subtract 8. A is only single digit. Its cube is subtracted. Because you are putting at the right place, automatically its value is whatever you have actually in mind. So the simplicity of the calculation is that you are working only with digits, not with the actual values of those digits. Because what is called place value. Yeah. Yes. All the one digit numbers and their cubes, that one has to know. Yes. Yes. Square root. Find B, find C like that. Yes. Right. Yes. A will be a one digit number. Which one? No problem. So let me try to write here. No. What is your number? 3. So I should draw. 3. Oh, I have to choose. pen. This also I should. Okay. Let me choose this red one. Let us say 3, 4, 7, 6, and this is 4. So first of all, you have these groups. Okay. 3 groups are there. Because there are 3 groups, there will be 3 digits in the square root. Five square, yes. Yes, right. 5 square I will subtract. That's right. Yes, because no, here every time the first initial groups are of 2 digits or 3 digits or like that, depending upon whether you want to find square root, cube root, like that. So in the Shakuntala Devi's case, she has to make a group of 23 numbers, 23 digits, because she is finding 23rd root. So what happens is, if she makes 8 groups, then it is not that 23 digits remain, less than 23 remain, but she has to make a 9th group for the remaining digits. So in all, 9 groups are there, and then one finds out. So first step is to make these groups. So Aryabhata calls this as, this is Varga Sthana, this is Avarga Sthana, then Varga Sthana, Avarga Sthana, Varga Sthana, and Avarga Sthana. So how many Varga Sthanas are there? That is the number of digits. Yes, so 3 Varga Sthana are there. So there are 3 digits in the square root. That is the method. This Varga, he has not mentioned, as you rightly said, that it is not mentioned by Aryabhata. But the other later mathematicians like Bhaskaracharya, they give it more clearly. Varga Sthana, Avarga Sthana, and so on. Kuttaka, yes. Kuttaka is kind of congruences. Kuttaka is congruences. Solving congruences, finding inverse, all that is there. So that is the kind of non-trivial mathematics that they used to do. So, okay. That I am writing. Vargasthana. Bhaskaracharya mentions Vargasthana or Avargasthana. There is a verse of Bhaskaracharya which I have to state. Actually, I have not read any commentary of Aryabhata, unfortunately. I have only read the translation of Shankya Abhyankar, which I have written here. Whatever I have written is the translation of Shankya Abhyankar. But if I read the commentary, then I will understand better. Shankya Abhyankar, whatever he writes must be here. Let me see what he has written. Sometimes he has given explanation. So, now you see. This is the explanation that he has given. शेवटच्या घनस्थानातून सर्वात so this is what Shankya. So I have written the explanation that Vishamasthana is equal to Vargasthana, because one has to understand the meaning of this, explain the meaning of this. So Bhagam Haret Avargan Nityam. So what is the meaning of Avarga? He has used it, but he has not explained what it is. But we have to make out what he wants to say. Because so many commentaries are there, so they will explain certainly. For example, Bhaskara 1 wrote Laghu Bhaskariya and Mahabhaskariya, so he must be explaining in any case, because Aryabhata wrote only 33 verses in Ganitapada. All mathematics he explained in 33 verses. Therefore, he doesn't explain more than this. Yes, everything that is, it is kind of usable mathematics. People who don't know much mathematics, they should be able to use it. So he gives the method and the formula. All these formulae here directly mentioned. This is the answer. You do these calculations, you will get the answer. So, but how that comes, that he never explains. For example, length of the shadow in trigonometry. So that he gives the final answer. without explaining the method. So even Shankar Bhankar has not mentioned here varga, but the avarga and vargat varge shuddhe. Vishamasthana, I have used this because what happened, once to explain, I have used Vishamasthana, this thing. But now this Vishamasthana, I have to correspond with this varga. So therefore I have myself have written Vishamasthana equal to Vargasthana, because that is the correspondence. First place, third place, these are all Vargasthana. Because we know Sama Vishama, so that we know. Yeah. But for Ghanasthana, what he has used is that he says Ghanasthana, second Aghanasthana. That he has used. So first Aghanasthana, second Aghanasthana. These terminologies he is using as we see from the next verse. So this is verse number 4 and verse number 5 should be here. This is, so in the verse number 5, he says Aghanat Bhajet Dvitiyat. Second Aghanasthana. Dvitiya Aghanasthana. That he is using. Dvitiya Aghanasthana means immediately after the Ghanasthana. So 7 is, in this example, this 7 is actually Ghanasthana, and immediately after that you get Aghanasthana, which is second Aghanasthana, because Ghanasthana, first Aghanasthana, second Aghanasthana is 5. That is what one is getting. And from that you subtract, first of all, he has not mentioned that initially, first of all, you have to subtract a cube. Subtract 8 first of all. That he has not mentioned because it should be obvious, obvious step for him. So he doesn't mention that. Once you do that, then you take this 5, this is second Aghanasthana, so you get 95, and then you should subtract this Trigunena Ghanasya Moola Vargena. So this 8 is there, its cube root is 2, Moola, it is Ghana Moola, its square, Varga. So 3 into 2 square, you divide by that. So Bhajet, so you divide. And then you get some quotient, and then subtract, then it takes like that. Vargas Tripurva Gunitaha. Purva is commentary, yes. More explanation will be in commentary. But later mathematicians, they wrote Sutra Paddhat. It is impossible, yes. But historically it is important. That's why I am going it this way. Otherwise, if you want to know only what is it, so one should study really Bhaskaracharya Lilavati. Because there is more straightforward in Bhaskaracharya Lilavati. And if you go to Brahmagupta, then probably it may be more, because Bhaskaracharya says that previous people have written much more unnecessarily. Means they have explained more. And so, what I am doing is, I am taking the main points from them and I am writing it Laghu. In short, I am writing this. But still it is much better than Aryabhata. What Bhaskaracharya writes is, because he understands that one has to explain at least these things more. Okay. So now, I think that this method of Bhaskaracharya, we don't know how they write, because XXX, yeah, right. So these people means some, yeah. So there are books in which I have seen this XXXX, for example, they will write 4 times. But some commentaries I have seen in general, there they used to write, for example, ya, before that something and after that something. Ya, 3 ya 3 would mean that it is 3 times ya is a variable and its cube. If you write after that, then it is like cube or 4th power, whatever. So some kind of, but they will not write on the top. So that writing on the top is some way discovered as after Descartes somebody thought that it is better to write in this way. And then people thought it is useful. Subscript, superscript, all that. So these are the terminologies developed later by.
Polynomials.
Yeah, polynomials essentially are there because they are solving these equations. Yeah.
Squares.
No, they are also having cube also. Cube is also involved.
Again,
Nth root. Yeah, higher powers they did not write, but Bhaskaracharya tried to solve some more difficult equations, but they were not, of course, general. What he will do is, for example, he will complete a fourth power and then write the sum of difference of two squares. Ultimately, he will solve. Yeah, yeah, because he uses that R raised to n in the geometric series. So higher power they would consider in any way, but how will they write is what you are asking. How do they write those things? But they will write something like this only. In many books I have seen, they wrote later on. Power. Mohan Apte. No, Shankara only translates. But Mohan Apte has written, this is only Ganitapada first of all, whatever Shankara does. But he does complete Aryabhata. Yeah. Means astronomy part also, he discusses. Yes. So, okay. So I think this is fine. This I explained how it goes and how one can, in principle, do this. And this is, even if there is decimal point somewhere in between, you can still find the cube root and you can do it up to certain number of places of decimal if you like. You can go on continuing and you can use groups of 2 zeros or 3 zeros depending upon square root, cube root, etc. And you can go ahead finding out the roots. Yes, so this principle behind it I have explained. Method of Aryabhata. Okay. Now the later, this is sixth verse. Tribhujasya phalashariram samadala koti bhujardha samvargaha. This is one formula. And another is urdhva bhuja tat samvargardham saghanaha shadashriditi. So, first of all, Tribhuja is triangle, phalashariram. So, phalashariram means Tribhuja means itself that body of the triangle, and then its phala is actually some value corresponding to that function, value of the function. The function is here area. So Shankara translates as Kshetrafal is that Sharira means body, and the value of that is Samadala Koti Bhujardha Samvargaha. So Koti Bhujardha, Koti Bhuja. So one is Koti is to be considered as height, and Bhuja is one side, that is the base, and then Ardha is half. So 1/2 base into height. Samvargam is multiplication, bring them together by multiplication. So it is equal to, Sama is equal to Samadala. Now Dala, I do not know exactly how you will translate. Bhuja, because Paya is one of the sides of the triangle. So Bhuja should be understood. Koti. Koti is height. Unchi. Paya means it is actually one of the sides of the triangle. Anyone we can take. And then corresponding height you have to consider. So it is bhuja, tribhuja. So one of the bhuja you take and the corresponding koti you take. So corresponding height you have to take. Take any bhuja and take corresponding height and then multiply by half. So ardha is half. So koti into bhuja into half, product of these three numbers, samvarga, that is the phala shariram. Phala is actually function. So here phala shariram means phala of sharira. That's what I could understand. So it is the value of the that body, value corresponding to that body. So it is sama is equal to, and dala actually doesn't have any good meaning. I do not know, because usually dala is also used for one half many times, because you say dvidala. So dvidala dhanya, kadadhanya vagare astat ti. So each part is half. So many times they have used dala for half. But here what has happened is he has also used ardha here. If he had not used ardha, then dala would have been actually half. And that in that sense it is used at other places, dala. So samudala koti bhujardha samvarga. So this is area of the triangle. Now urdhva bhuja tat samvargardham. So this is the Ghanaha Shadashri. Now he is trying to find out the volume of Shadashri. So Shadashri means some body which has 6 edges. Last time in the previous one there was Dwadashashri, 12 edges are there. Here there are 6 edges. So one understands that it is a tetrahedron because tetrahedron has 6 edges. So Shadashri, what is the volume of a tetrahedron? So here tat means whatever you have already obtained. Tat means you have already obtained something, this thing. That is the area of this triangle. So you should consider this base triangle and its area, you know the formula for that. Now you multiply that with urdhva bhuja. So urdhva bhuja is to be considered as the height. So from this you go to the top, and what is the distance that you have traveled essentially. So that is urdhva bhuja, and tat samvarga, that means you multiply base by height and take half of it, ardha. So this formula is wrong actually, but he has given this formula somehow. And some people have commented that actually Aryabhata has 1/3 in mind. Why? Because he has solved other problems in which there is 1/3, and he should understand that. But he has made some errors in the volumes of solids, and this is the first error. And sometimes there is some typing mistake, and therefore it can match ultimately. But here there is no way of matching it. Ardha to be replaced by something which will mean 1/3, and somebody has made a typing mistake, but we do not know. Huh? You have to cook up some name for that. 1/3 means you have to. You say divide by 3 only, you write in words. Just as ardham, there is no 1/3 means tritiya ansha, you can say, if you like. And then he may be having some way of shortening that tritiya ardha. Tritiya ansha, chaturtha ansha. Padam is used for chaturtha ansha. Padam means 1/4. Now 1/3, I don't know whether there is some good word which may replace ardha. Because they say that he knows actually this thing. And then this was correctly written by Brahmagupta. Brahmagupta has written the correct formula. Now, probably Brahmagupta, I do not see anybody who says that Brahmagupta says that Aryabhata is wrong. Usually Brahmagupta comments on Aryabhata and he says how he is great and Aryabhata makes mistakes. Okay. But for this formula, at least I have not seen that somebody is saying कि Brahmagupta comments कि मेरा formula सही है और उसका wrong ठीक नहीं है उनका. So that is also, in any case, let us. I have not seen that there is a comment. I have not seen. One has to really go through that. and whether he comments like that. But at other places he has commented that I know. Some other places. So now this is the only Shankya Abhyankar says He Sutra Thik Nahi, so it is not correct. It says. But this method of using the previous formula is used by many people. So this formula, for example, Bhaskaracharya gives a formula for area of a circle in one verse. Then he says, whatever you have obtained, that is pi r square, area of a circle, multiplied by 4. Just as he says tat here. Whatever you have obtained, that you use and do something with that. So he says pi r square, you multiply by 4, you get the surface area of a sphere. Okay. Now, whatever you have obtained means 4 pi r square. You multiply by r and divide by, so multiply by diameter and divide by 6. So that is 4/3 pi r cube. That is the volume of the sphere. 4/3 pi r cube. So in one verse, he says, first this is pi r square, multiply by 4, then multiply by diameter and divide by 6. So r by 3. So in one verse, he gives 3 formulae. And this is a method that they are using. Okay. Now, this is now some time left. Ayama gune, so samalamba vishama chaturabhujache kshetrafal. So we have this trapezium. Ayama gune parshve. So basically, he wants to get two things he wants to get. One is area of the trapezium, and another thing he wants to get is that this is the trapezium that you see here. There are two sides which are parallel to each other, which are important, and there is one height here which is given to you. But suppose this height is given. Now these diagonals, they intersect each other at some point. So he also finds this height h and the below height h dash. These two heights also he finds out. So what is given is the two parallel sides of the trapezium, and the height of the trapezium is given to you. And he gives formulae for these two small heights h and h dash from this point of intersection of the two diagonals to this side and the other side. So these two formulae also he gives. So what he says is ayama guna, ayama is to be understood as, so I think this draw this I will so still it is drawing. Okay, all right. So now ayama is to be considered as height. Ayama dictionary meaning last time Medhalime madam has said it, it's something stretched. So how much it is stretched? So you have to understand it this way, that there is below line and you are stretching it to ups, and these are parallel lines you are getting. So what is the distance between these two parallel lines? That is called as ayama. Ayama gune parshve. So these parshvo is to be understood as this side or this side. These two sides which are parallel sides, these two sides are there. You multiply these sides respectively by the height separately. Then so base and mukha. So this and this you multiply by the height separately, and then you divide by the sum of base and top. If you do that, then you get the two heights h and h dash. So basic derivation is like this, that this h upon h dash will be equal to mukha means this top part and paya is base. So top upon base. That's what it is. Now you just add 1 to both sides. So you get h plus h dash upon h dash is equal to mukha plus paya upon paya. So top plus base upon base. And now from that, h plus h dash is total height. So unchi or height upon h dash, that is equal to mukha plus paya upon paya. So top plus base upon base. Now you can find out h dash from this. So h dash is equal to height into base divided by the sum of these two numbers. So that's what it says, that base or top you multiply separately by the height. So base into height, for example, and divide by the sum of these two numbers, top and base. Then that gives you the heights from the center. This point of intersection is here. Point of intersection, the distance of points of intersection from the two parallel lines, that is top and base. So those heights you get by this formula. And then if you want the area of the trapezium is 1/2, then sum of these two parallel sides. So base plus top multiply by height and divide by 2. So ayama is here. Ayama is height. You should multiply by Vistara Yoga. Vistara Yoga means sum of the two sides. Vistara, I think it is Vistara kind of thing. So these two sides which are parallel to each other, you take their sum yoga and multiply by half, ardha, multiply by half, and then that is what the kshetraphala or area is for this trapezium. Okay, so ayama is to be understood as height here, and if you understand that, then the two formulae we get here, geometrical formulae, that okay. Then now after this we will stop. Previous slide. Yes, I will. HR okay. This I wanted to explain, they did not do. So here he says, half we have seen that samaparinahasya ardham vishkambardha hatameva vruttaphalam. Vruttaphalam is area of the circle. Vrutta is circle and phalam is its area. How it is to be obtained? So samaparinahasya ardham. Parinaha is paridhi or circumference. Then you take half of that ardham. Then you multiply it by Vishkambhardham. It is not Vishkamba, but Vishkambhardham. Vishkambha is again diameter. Diameter, half of that is Trijya. So 1/2 into circumference into diameter. Diameter half, that is Trijya. So in our usual notation is pi. If you want to use, then it is pi r square. So half paridhi. Paridhi is twice pi r and multiply by r. Vishkambhardha. So this is pi r square. And now in the remaining part he gives Ghanaphala. So that is the volume of a sphere, which is a wrong formula which he is giving, because the correct formula, as I mentioned last time, was given by Bhaskaracharya. Before that, nobody was able to give in India correct formula for volume. So how he thinks this formula, that is very interesting, that if you take volume of a cube, then it is a cube, small a cube, where a is the side, volume of a cube. So area of a square is a square, a into a. From that 2 dimensions to 3 dimensions one goes, then you multiply by a. That's what the observation is. So a square into a is volume of the cube. But a is square root of a square. So he thinks that probably 2 dimensions to 3 dimensions if you go, then you should multiply by the square root of the previous number. So that's why he says, tan nijamulena hatam, whatever you have obtained, that is pi r square, you multiply by square root of, nija means whatever you have obtained, its square root. So multiply pi r square by square root of pi r square. Ghana gola phalam, that is the volume of the sphere. That's what he thinks in that way is what I think. This may be his argument. So, and then he says it is Niravashesham, means it is exact according to him. Niravashesham, nothing is remaining. Avashesh is not there. So, this is the final formula. That's what he thinks. So, this is a incorrect formula.
There is statement about volume of parallelepiped.
I don't think value of a parallelepiped statement is no. I think volume of a cube is there, but not parallelepiped, because they did not even parallelogram they have not considered. I think parallelogram they have not. They considered square, rectangle, these things, triangle, but not parallelogram. But there are some formulae are there for some complicated figures, which
Rectangular parallelepiped में सारा formula है,
hmm,
ABC.
hmm,
तो पूरे straight झाला पाहिजे पण त्याला
right. Then they are corresponding to that
Euclidean measure.
Euclidean measure. Right. Hmm. So far here at least, so parallelepiped, those things are parallelogram. Even parallelogram, it may not be there. I think. Have you seen anywhere in Lilavati somewhere parallelogram? Concept of parallelogram. Ah,
Triangles.
yes, they can get it.
त्या
झाला.
rectangular
Rectangle तर आहेच. म्हणजे
yeah.
because he has methods of conversion of a rectangle into a square, square into rectangle, so they are compatible with those notions.
Straight केलं का
I don't think it is rectangular parallelepiped or
Hello.
hello. We have to see. Probably,
हा असं होतं. त्याच्यानंतर triangle माहिती आहे ना, पण triangle तो बनाव the base and the height.
that they know. They can calculate all that because rectangles of माहिती आहेच, बरोबर आहे. कारण what he says is, you divide into triangles and squares and so on and get the area of arbitrary thing. That he has mentioned. In general also, this last verse, he gives them sarvesham kshetranam prasadya parshve phalam tad abhyasaha. So, what explanation of Shankar Abhyankar is that if there are arbitrary such figures and you want to find their total area, then you bring them into some rectangle and then approximate this by the area of the rectangle. Yeah. And then he gives, this is one formula, Sarvesham Kshetranam Prasadya Parshve Phalam. So Parshve means they bring them together. Like that. Then you can get the Phalam, Kshetrafal. And here, Paridhe Shadbhagajya. So Paridhi is there, so circumference is there. Then you take 6 parts, 6 equal parts of this circumference. And then if you take 6 parts, then what is the ja? So this is the ja that is seen here, red one, corresponding to this 1/6 of the circumference. What is the value of this ja? So he says that that is equal to radius. Vishkambha is diameter and ardha, so that is radius. So it is equal to tulya. It is that ja is equal to the radius. परिधीच्या 6व्या भागाची ज्या ही व्यासार्धा बरोबर असते. So these two formulae he is giving here. First is not formula but a method which can be used to find out areas of arbitrary fields whose irregular. Okay, so we stop here today. Okay,